Hello and welcome to Vodcast 13.1. In our first vodcast for Chapter 13, I will overview air pressure. By definition, air pressure is the force exerted by the weight of air above us. At sea level, that weight of air is 14.7 pounds per square inch. Now to help you conceptualize that, I want you to take a look at my hand because I've drawn 1 square inch in my palm. Hopefully you can see that. I think it's centered pretty well. Now I want you to imagine me going outside and holding that square inch upwards towards the sky. If we had a weightless column extend along the edges of that square inch in my palm all the way up to the very tip top of the atmosphere, I would be holding 14.7 pounds of air in that little square inch column. Now if you look at my palm one more time, you can see there's a lot of square inches I could probably draw on my hand. So it's very fair to wonder, how could we hold so much weight? Well, here's the secret about air pressure. Air pressure surrounds us. So when I hold my hand skyward, it's true that there's a weight of 14.7 pounds per square inch acting on my palm. But that very same weight is acting on the bottom of my hand, and the side of my hand, and all around my body. Another important fact about air pressure is that it decreases with increasing altitude. In a previous podcast, I showed you this image you currently see on the screen. And as we work our way higher and higher into the atmosphere, there's less and less weight of air above you. If you start at the surface and look up, you essentially have the entire atmosphere above you. But as you work your way to higher and higher altitudes, there's going to be less air above you, so the atmospheric pressure will decrease. Now when it comes to measuring air pressure, we have 2 units that we can use. The first is known as the millibar, which is abbreviated lowercase mb. At sea level, which essentially means you're standing right next to the ocean, standard pressure will be 1013.2 millibars. If you happen to be in an area that's higher than sea level, which we are in the Midwest, that number will decrease slightly, although the extent to which it decreases is a function of how high you are above sea level. The other unit we can use to measure air pressure is inches of mercury, and at sea level, standard pressure in units of inches of mercury is 29.92. Now, it's very important that I state this in the first vodcast for Chapter 13. We just talked about standard air pressure, but air pressure is changing all the time. In terms of measuring air pressure, we have 2 ways to do it. The first is known as the Mercury Barometer. It was actually invented by Torricelli back in 1643, so a very long time ago. I'd like you to look at the image that shows a Mercury Barometer because it shows a pretty important concept. There's a glass tube that's filled with mercury, and then you have mercury sitting in a little dish-like container. Now the air pressure will act on the mercury in that dish from above. Now if we have a situation where the air pressure is high, the air pressure will be able to exert a lot of force downward on the mercury in the dish, and as a result the mercury in the column will rise. By that same token, if the air pressure were to decrease, we would see less pressure acting on the mercury in the dish. You can almost imagine those arrows as letting off a little bit, and when that's the case, the mercury level in the column will decrease, because more of the mercury will be able to fill the dish, now that there's not as much air pressure acting on the mercury in the dish. Now the other way we can measure air pressure is the Aneroid Barometer, and the Aneroid Barometer does not use liquid. It actually contains an expanding vacuum chamber, and that vacuum chamber can get compressed as the air pressure increases, or it can expand if the air pressure is decreasing. And as that air chamber expands and compresses, the needle will move around on the barometer to indicate what the air pressure is. Now, at the risk of getting ahead of myself, I want to tell you 2 very important things about changing air pressure. If you were to monitor air pressure throughout the day, and you notice that the air pressure is gradually dropping, you should pack rain gear, because odds are stormy weather could be approaching. However, if you notice that the air pressure is rising, you can anticipate sunshine and fair weather. So rising air pressure basically tells you go outside, have a blast, you probably don't need rain gear, although it would definitely be a good idea to pack some sunscreen. Now what's going on that makes dropping air pressure associated with bad weather and rising air pressure associated with good weather? Well, we'll talk more about this at length in future vodcasts, but if we rely on some of the concepts we already know, one of the 4 processes that lifts air is convergence. In last chapter I overviewed how convergence can lead to cloud formation. Well, if low pressure is approaching, there will be convergence occurring in that region. And as a result of convergence, air will be forced aloft, clouds will form, and there's a good chance that if the conditions are right, you might get a storm. But quite the opposite happens if high pressure is approaching. With high pressure, instead of convergence, we have divergence at Earth's surface. In other words, instead of having air approach other air head on, we see air moving out from a high pressure center in all directions. So if high pressure is approaching, you probably won't see a whole lot of cloud formation occurring in that area. We will build on all these ideas in more detail in future vodcasts, but for now, that is the conclusion of Vodcast 13.1. In the next video podcast, I will overview some of the factors that affect wind.